Australia. Professor Richard Mackey, you're welcome.
Well, thanks for inviting me. I'm speaking from Canberra, where it is almost summertime. And I wanted to share some observational detail about the Earth's rotation and its relationship with climate dynamics. That's the index to my presentation, and I have about 31 slides to talk through. Over the last 50 years, geophysicists in a whole string of publications have established that the planet experiences episodes of warming and cooling that are repeated about every 60 years. But these cycles appear to be driven by 6 or 10-year variations in the rate of rotation of the Earth. But these variations result from oscillations of the Earth's inner core, and these oscillations have their origins in the celestial mechanics of the solar system as documented by Pierre Laplace in 1799. The episodes of warming and cooling are connected to the Earth's rotation. There appears to be a time lag of about 8 years between the change in the Earth's rotational speed and surface temperature. And there's a time lag about 8 years between an electromagnetic event that kicks off the variation in the Earth's rotation and that rotation happening. In an article about Laplace, a group of French scientists, which Lopes was a key author, showed that there are 4 causal processes that determine changes to the rate and inclination of the Earth's rotation in accordance with Laplace's equations. One of these, the first is that the planets, particularly the Jovian planets, act on the Earth-Moon system. The second is that the Sun acts on the Earth-Moon system and on the rest of the solar system, of course. And all the planets of the solar system act on the Sun, and the Sun, having been activated by that, proceeds to act on the rest of the solar system. In that article, those scientists confirmed that Laplace's 1799 analysis that the motion of the rotation axis of the Earth is determined fully by the gravitational potentials and kinetic moments. Laplace showed that only the gravitational forces and kinetic moments from other celestial bodies influence the rotation of any one of them. So that's background. Now, in 1976, Kurt Lambach and Annie Kazneve published a series of papers based on detailed observational data. They concluded that the long period of greater than about 10 years variations in the length of day observed since 1820 show marked similarities with variations in the various observed climate indices. They reported that, and this is based on observational records, no climate models or whatever, that periods of acceleration of the Earth corresponding to years of increasing intensity and zonal circulation global surface warming, periods of deacceleration corresponding to years of decreasing zonal circulation and intensity and a decrease in surface temperatures. They then explained in terms of a detail that Horace Lamb had set out in his 1972 treatise on climate past, present and future, how that change in the Earth's rotation related to what Lamb had documented as type 1 and type 2 patterns of atmospheric circulation. Quite detailed. They also argued that the cooling that the planet had experienced in the 1960s and 70s arose from a slowing down of the Earth's rotation in the 50s. They wrote in that paper in 1976, if the hypothesis that decadal rotation decrease or increase results in planetary cooling or warming is accepted, then the continuing deacceleration of the rotation of the Earth for the last 10 years suggests that the present period of decreasing average global temperature will continue for at least another 5 or 10 years. And they added that perhaps a slight comfort from this gloomy trend is that in 1972, the length of day, which is the measure of rotation, showed a sharp positive acceleration that has persisted until the present, 1976, meaning that a period of global warming would begin around 1982, 87, and that period actually began in the 80s after a lengthy period of cooling. Professor Lambeck wrote a treatise on the Earth's variable rotation, and in that book he summarised the main findings from his joint papers with Dr. Chcete-li, and he included these two graphs, which are a bit awkward in that picture, but they're in the book, which shows figuratively the relationship between the type 1 and type 2 patterns of atmospheric circulation and the changes in rotation. And this graph, which shows the variations in the Earth's rotation, which is a solid line, and global surface temperature, which is the broken line. The two scientists worked with the best data they had at that time, which wasn't very good. Now, since then, quite a few other scientists have reported similar findings. Dr. Sidorenkov from Russia published a book in 2009, Interaction Between the Earth's Rotation and Geophysical Processes, in which he reports quite a lot of observational data. Americans, Dickey and all did the same. Nikolai Scafetta and his colleagues did similar. Professor Roselot from France did similar. And in 1999, the National Report of the Federal Republic of Germany about the geodetic activities in the year 1995 to 99 summarised the work of Professor Jochman and Dr. Greiner May. That report concluded they showed that the Earth's climate cycles are related more to the core dynamics than to atmospheric circulation. Then there's a lot more published. Zotov, French, Italians, Dr. Morner, of course, wrote extensively on the subject. And most recently, a very interesting paper by Julia Pfeiffer, Annie Kaznevi, and a bunch of other colleagues, based on a most extensive analysis of satellite data and observations about the dynamical processes in a core, report a 6-year cycle. Now, their data was of far better quality than what Lambeck and Kaznevi had. That's the most recent. Then I found this interesting paper by some Chinese scientists who analysed the influences on the variation of the rate of the Earth's rotation on atmospheric and oceanic motion in the low latitudes using standard rotating shallow water equations. And they showed how that connection occurs, specifically in terms of the propagation of Kelvin waves. I thought that was a very significant paper, but it was a bit hard to find. On the relationship with the Earth's rotation and seismic events, the interesting book by this chap, Ostrom, about how Sir Harold Jeffreys dominated geophysics during his period. He was a very influential human being, and he was a very significant human being in terms of his contributions to science. But he dogmatically and strongly opposed the idea of continental drift, and he dogmatically and strongly opposed the idea that there could be any relationship between the Earth's rotation and crustal displacements. And those views dominated. Dr. Nicholas Stoyko of the International Time Bureau in Paris, he and his wife, they documented correlations between length of day variations and seismic activities. The American geologist Don Anderson reported a striking correlation between decadal variations in the Earth rotation, seismic activity and volcanic activity. Two American scientists, Benedict and Wilhelm, outlined in detail the way in which decadal rotation changes trigger earthquakes in a similar way to that suggested by Anderson in 1974. That's a sort of a picture of the way the world is, with the inner core being connected by these electronic sort of things. This is from a recent paper by a couple of Chinese scientists, one in America and some in China, that gives a depiction of how the whole thing works, with the inner core oscillating and then that oscillating being communicated through to the rest. And basically an idea of a resonating Earth system from the surface to the inner core. So to recap, it's been pretty well established that there's a 6 or 10 year variation in the Earth's rotation is a key determinant of climate dynamics. Of course, overlaying that are a whole lot of processes that originate with the sun and the moon. Gravitational fields, electromagnetic fields, the output of radiation and matter, the sun's own motion, and how that influences the rest of the solar system. The heliosphere's structure changes a lot during the solar cycle, and that has an effect. Then I think it was Dimitri pointed out that the atmospheric oceanic systems of our planet have their own dynamics, which give rise to periods of warming and periods of cooling and a whole lot of other things. But the whole lot interacts, and the interaction processes are critical and difficult to follow. But the gist of that is that there is a reasonably well-established 6 or 10 year variable rotation which arises from the interaction of essentially the solar system with the Earth's structures, inner core, outer core, and mantle. And that process gives rise to longer cycles of 60 years and 180 years and so on. Now, I spent some months poring through the IPCC's report, and I found no reference whatsoever to any of this work. And that was surprising because Professor Lambeck's book is a key standard textbook on the Earth's rotation. And then I found that the established bodies that are the font of all wisdom consider scientific misconduct, among other things, as not representing in the research record accurately by deliberate omission of scientific results. That constitutes a falsification of science and scientific misconduct. The US Office of Science and Technology, US Academy of Engineering, and so on, endorsed by the OECD. Throughout the 25-year existence of the IPCC, it has refused to mention any of the many reports on that topic, any of the reports that relate to the variable rotation of the Earth and climate dynamics. No mention whatsoever. Clear case of scientific misconduct. About 7 years ago, a team of mathematical physicists showed that the Kelvin and Yanni waves that sweep eastward, abutting the equator, were a necessary consequence of the topology of a rotating, almost spherical Earth and the Coriolis force. They showed that analytically, but then subsequently colleagues of theirs examined the vast databases about behaviour of the atmosphere maintained by the European Centre for Medium Range Weather Forecasts, and that established that the Kelvin and Yanni waves are determinants of ENSO and irrelevant to Rossby waves. Those findings have since been extended to the Madden-Julian oscillation and coastal Kelvin waves. So the message is therefore that there are cycles of global warming and cooling that are connected to the Earth's rotation variations. There's a time lag of about 8 years between the changes in the Earth's rotational speed and the surface temperature. And there's a time lag of about 8 years between electromagnetic events that kick off the rotation variations and the rotation variations happening. To my mind, there's an elegant simplicity in all of this, and given this is only a part of the theory of climate dynamics, so it's not the whole story, but at least it indicates that there is a theory of climate dynamics that applies to the solar system, just as Ned and Carl have emphasised in their papers. A theory of climate on the Earth has got to be part of the theory of climate on all the planets of the solar system, of any solar system for that matter. And that's essentially my the findings I wish to report and the findings I wish to share. They're part of a bigger story. They're not the sum total of it by any means. And the task of integrating those findings with other findings is a task yet to be done. So hopefully you could hear some of that and it wasn't too incoherent. And that completes my presentation.
Hello, Richard. This is Jan-Erik Solheim. Thank you very much for publishing in the Science of Climate Change journal. Your very nice work.
Oh, yeah?
Can you hear me, Richard?
I can hear you.
I have a question for you.
I guess everybody's gone off to get coffee.
Oh, that's all right.
Yeah.
It's about...
it's a bit like Parliament when there can be some crucial debate. There might be about 6 people present.
I find this a fascinating topic.
I have a question.
I think one of your final slides indicated that it was this Earth's rotation that controls climate.
Yeah,
you're talking about the very short time scale of about a decade or so.
Yes, that's right.
And so that's important. But I mean, when I get to my talk in a couple of hours, I can make observations about what might be happening on the longer time scale, but I actually haven't a clue how to find a physical explanation for what's going on. And so I hope that maybe in the future we can begin a kind of a dialogue to work out what is going on the multi-millennial scale.
Yes, because this is only a bit of a much more complex picture. There's a lot of other things happening as well. But what I found most interesting was that it's totally ignored by the IPCC. And the IPCC has produced thousands and thousands and thousands of pages of reports. It just doesn't make sense.
Yeah, when I agree with that. But there's this issue of the so-called climate scientists refusing to engage in any sort of dialogue.
Yes, that's right. Well, that's another thing that Nick and Carl have reported, that Ned and Carl have reported. Their attempts to try and get to the bottom of what is quite obviously a fabrication of data. The scientists who work for the IPCC just won't engage. And that's been the pattern for those 25 years. In a paper I did with published in that the journal that the Norwegians did it, I reported the extent to which a couple of quite significant Australians here who were highly critical of the IPC. This is some in the early days. One of them was the Australian statistician, and the other one was, I think, Secretary of Finance. But they were just treated as idiots by the IPCC leadership, and that's the pattern throughout. It's just bizarre.
Yeah. And in the criminal investigation world, this is called lying by omission. Which is exactly what you're alluding to, is that if you're in an investigation and or if you're being investigated and you deliberately omit some vital evidence, then it's called lying.
Yes, that's right. Well, what Ned and Carl find is not simply lying, but this guy multiplied a lot of series data by -1, so he got the graph to go in the direction that the IPCC required. Because had he not multiplied it by -1, it would have been in the opposite direction. In this whole thing, I think the paper I find most compelling is this one by Julia Pfeiffer, Annie Kesneve, and a bunch of other colleagues, because it's all based on the examination of satellite data, and on the one hand, and detailed data about the Earth's geomagnetic field on the other. It's a very compelling paper, and that finds a 6-year rather than a 10 years old.
Richard.
The data is so much better than the data that was available in 1976.
Richard,